Hi everyone, welcome to this week's Learning Space. My name, which is not on my lower third because it's broken, is Nicole Gugliucci. I am a postdoc with CosmoQuest, and we bring you, I have my co-host, Georgia Bracey.
Hello.
Hello. And we have special guests, Jehan and Janine. So hello.
Hello.
So we are a weekly show about topics in astronomy and space science, education, and outreach. And so thank you for joining us once again. The Hangout toolbox is all different and changed, and I can't make my lower third work, so sorry about that. But all the other awesome people have their names up. So
You don't need lower third, Nicole.
yes, you're all seeing my mug every week. Gosh, it's true. You'll see my silly mug. But also there's been changes to the comment tracker, and so I am watching the event page comments separately from the comment tracker because I can't figure out how to get them in the new system. So be sure to use the event page for your comments. I'll be watching that, and then the comment tracker is picking up the YouTube comments as well. Fingers crossed. If one source seems not to be working, try the other. So feel free to ask questions of our guests or comment along as we go. We already have a hello from Lourdes. Hello, Lourdes. So why don't I start off asking Jehan and Janine to introduce themselves and the research that they do, and then we'll get to talking about the blog.
Sounds good. All right. Well, my name is Jehan Kartaltepe, and I am a Hubble Fellow, which is a postdoc, at the National Optical Astronomy Observatory. So that's NOAO for short. So NOAO runs the Kitt Peak National Observatory facilities. I actually don't work with those facilities. I just work on research here as a postdoc, and I work on galaxy evolution broadly. I'm mainly interested in galaxy mergers and how when two galaxies collide with one another, that changes the course of a galaxy evolution and how they have changed over time. So I'm mainly looking at galaxies that are really far away from us in the distant universe. And in order to do this, I participate in a number of large surveys. And so one of the surveys is one that we're going to talk about today called CANDELS. So CANDELS is the largest HST survey to date, which is studying these galaxies in the distant universe. I'll let Janine introduce herself.
Hi, I'm Janine Four. I'm also a postdoc at NOAO, and Jehan already told you what exactly that stands for. I'm working for the same survey for CANDELS, and my tasks there are mainly to derive galaxy properties, so you know, how heavy is a galaxy, how old is a galaxy, and to do that for all the galaxies that we have in the survey, and then if you know how far away one of those galaxies is, you can constrain galaxy evolution with that and see how they actually evolve over time. I'm also not really using any of the Kitt Peak telescopes. We like the space-based ones.
That's fine. That's fine. I personally could not handle having my dissertation on a rocket ever, so I set it down base.
Well, as a postdoc, we don't have any functional duties, so everybody else at the observatory has duties with the observatory. We get to spend 100% of our time just on research, so that's why we don't have that direct connection.
And some spare time on CANDELS outreach.
Yes.
Yes, all that copious free time you have.
Exactly.
So maybe you guys can tell us a little bit more about the CANDELS survey. So what is that? So that's using the Hubble Space Telescope. What is that survey, and what's kind of the overarching goal of it? How much data does it have? How many people are involved? What's the scope of this project?
Well, after the most recent Hubble servicing mission, a new camera was installed called Wide Field Camera 3. And the new exciting thing about this camera is that it's observing the universe in the near infrared instead of in the optical. So a lot of previous surveys were conducted in the optical. The benefit of a large survey in the near infrared is that for galaxies that are far away, their optical light that they emit is shifted into the near infrared. So we see them differently than we see local galaxies. And so by using this specific camera, we can see galaxies in a comparable way to the way we see galaxies in the nearby universe. And so this is perfect for galaxy evolution studies, so we can compare things one-to-one. The idea of the survey is we are observing 5 different fields, all in different portions of the sky. But these are 5 fields that have been well studied for many years. So in addition to our near-infrared data, there is data from a number of other facilities, both in space and from the ground. So we can put that all together, and Janine can then use that information to determine some of their properties.
Yeah, I do need the coverage in a broad wavelength range in order to be able to tell anything. And each of those fields has about 40,000 galaxies in them.
Wow.
Times 5, that's a lot of galaxies, like 200,000. We're still waiting for data on the last field. It's all observed now, but the catalogs aren't ready yet because the images just are all the data's just been taken. The images are being processed now, and there needs to be, sources need to be detected, and then you can extract the information of how bright they are, and then we have catalogs and can use them.
Yeah, so we're at an interesting milestone right now that all of the data has been taken, and it's taken 3 years.
Oh, very cool.
Really large. It's all been all finally taken, and the images are in hand. But that's really when the real work starts, of trying to derive all of the interesting information from the images.
Yeah.
So I guess I could say some of the main science goals. So we only work on really small parts, right, our own science interests. But there's something like 150 collaboration members, and these are all over the world, in many different countries. Other professional astronomers, their students, their postdocs, and all working on different aspects, but sharing the same resources. That's really the main idea behind a collaboration like this. And one of the main science goals is to study the earliest galaxies in the universe. How they formed, what did they form from, how quickly are they forming stars, what happens to them. Those are some of the big questions that a number of our colleagues are studying. We're sort of more interested in what we colloquially refer to as cosmic high noon. So not the earliest galaxies, but galaxies at the point in history where we think the most things were happening. Right, things were the most exciting. The most stars were forming. Black holes were growing the fastest.
Right.
Have accumulated most of their mass, and we're more interested in figuring out what was going on then. Why was that such an exciting time? What were the main causes? What's driving? What processes there are?
And there's another part of CANDELS which mainly focuses on supernova science. So CANDELS was merged between two observation proposals. One wanted to go deep, and the other one wanted to go wide, and look at things over and over again. And with looking at the same portion of the sky in frequent time intervals, you can actually check if a supernova has gone off somewhere, and with that you can study supernova. So there's a separate part of the team that only looks at all the supernova signs, and they found the highest redshift supernova so far. So there's lots of really, really interesting parts within the team going on, and people working on a lot of different things.
Wow, this is really cool. So this is a very broad and expansive chunk of galaxy evolution science that you guys are doing with all of these data. Yeah. So so the blog that you guys do, so I met you guys at the Astronomical Society of the Pacific, ASP. And so you were presenting on the blog for this. So I've put the link up on the event page, and it's candles-collaboration.blogspot.com, where candles is CANDELS. So go check that out. Or if you just type, I think I just Googled for candles blog, and it came up. So as long as you have the right spelling, you're golden. So why don't you tell us a little bit about this blog as an outreach tool for the candles collaboration?
All right.
Maybe how it got started, or
Right.
So Janine actually leads a subgroup in the team that works on public outreach. And so early on, we were brainstorming for different ideas about how we can do outreach. And somebody suggested the idea of a blog, and then sort of over time, it became a little bit more focused into specifically being an outreach blog and specifically being for the general public. And so the idea behind it is we really want to convey the science we're doing. That's the goal. We have this huge amount of Hubble Space Telescope time. It's all funded by the public, by taxpayers, and we'd like to be able to, of course we write our papers and we tell other astronomers what we're doing, but we'd also like to take what we're doing and convey that to other people that might be interested in a way that they can understand. So we want to present our results But at the same time, we present a lot of different background information so that people can put those results in context. So for example, if I write something about a paper I have on galaxy mergers, it's nice to be able to point to a post I wrote last year, which is really what galaxy mergers are, why they're important, how we study them, etc.
Yeah, and for example, I've written blog posts where I just explain the basic method on how we get those, like a stellar mass of a galaxy, for example, how that just works, why we need the different wavelength ranges and the images in the different wavelength ranges, and how you compare that with models and actually then get your answer and can use that before we start going into the really deep, here's this paper and has this result, and then people would have no idea. It's like, well, why do we care? How do you even get there? I don't understand. It's too complicated. So we have like a mix of both. We really have the background posts that we can always refer to and can say, these are the really basics. Like, for example, we have some on what are AGN, active galaxies, and what are supernovae. And then we go really into, like, this is what the team is currently working on. This is the actual science right now. The meetings that we go to, just to tell people, give them a general idea what it means to be an astronomer. Because let's face it, at the beginning of my undergraduate, I didn't really know what an astronomer really does on a day-to-day basis. That was like a vague idea of, like, you do some research, but you go to a lot of meetings, you go observing, you have to write observing proposals, job applications for other funding and grant money, and it's a lot of aspects that I think people that are not involved with research or the field really don't know. So we wanted to convey them, like, this is also the team people in the team do XYZ in science, but they also this is their day-to-day life. This is what their work means, what they're doing on a daily basis as an astronomer.
So I think that's been a fun aspect for us, is sort of putting the human side behind what we're doing. I wrote a post about going on an observing run. Well, people don't know what you do when you go to a telescope, right? Or that how dependent on the weather you really are, or things that happen when you're there. And so we sort of been able to add that element. We started a series, which is the Astronomer of the Month, and it's basically just an interview, so it's a set of questions, and we have a different team member every month answer these questions. And it's things like, what made you interested in astronomy? When did you decide to become an astronomer? What is your favorite aspect of your job, etc. And those have actually been a lot of fun, and we've gotten some of the best feedback. Because people Google things like this. And one of the fun ones, so we have a colleague that works at NASA Goddard, and so she wrote a post titled, "What's it like to work at NASA?"
Nice.
Surprised how many people actually Google this. They want to know.
Oh, yeah, I can imagine.
Yeah. What's your job like?
Of course, today isn't a very good day to be talking about that.
No, today she's at home.
Yeah. No, but those are great kinds of posts to write. How science works, how you get the data. So beyond just explaining what it is, people rarely understand, how you get it in the first place and what you do with it, and that whole process. That's sort of behind the scenes, and that's fantastic that you guys do posts like that, because that's really helpful, and I think the general public, wants to know that, and you don't always find that.
Those have been really popular, and for example, I don't think lots of people know how you get telescope time. They think you just show up at the telescope and observe whatever.
Yeah, who would know?
If everybody would do that, we would have a huge crowd at every telescope, right?
Or you got to pay someone off, yeah.
And it's actually quite a complicated process to get to the point where it's like, yes, here you have time and you need to compete. And I think people just don't know this, and it's nice for us to also tell them, like, this is how it works and this is what we're doing.
Or just the scientific process in general, right? Yeah. We've tried to convey that we don't have all of the answers. Here are some of the questions. Here, we're sort of chipping away at things. But look, at this conference, person A found this result, and we found this other result, and then we had a discussion about it. And I think that is really useful for a lot of people that don't understand how the scientific method works and how we're, sort of constantly changing what we know about the universe.
Sure, yeah, and this is important for understanding the scientific method. Is important. I mean, I think for everybody, even if galaxy evolution isn't your thing, this is the same method that's being used to investigate climate change, which is something that has direct impacts on the world, and so that's a big deal. And yeah, I agree, and I feel the same way as you do. It's like, hey, we're using public money to do this awesome science. Let's share it with you. You know, that's so important.
And to be honest, every person I've come across that asks me, oh, so what are you doing? And you say you're an astronomer, they're all like immediately interested, right? It's like, oh, that's cool, and what are you doing exactly? And where are you going right now? And then most of the time, like, you're on a plane going somewhere to a conference or something. So it's always a conversation starter, and people are always interested, and it's nice to share it on a broader level.
And one of the surprising benefits was that, you know, our families and friends will read it, and I had, you know, my friends over Christmas, we were talking like, I finally know what it is you do.
That's awesome.
I have no idea what you do when you go to work, and it gives them an insight into what life is like.
I know. I think a lot of people ought to write those kind of blogs, because there's so many people. What do you do? Blog about it. But I think people love to hear the day-to-day stuff too. So even if they might have a sense of what astronomers do, but it's that sort of daily grind kind of stuff in a way, trying to get telescope time, going to meetings, all that. You know, it's all part of the process, and I think people like to hear that too, because they can kind of connect to it in a way.
Yeah, we all have meetings.
You might have to go to meetings too.
Yeah, very cool. So what has it been like for you guys integrating this into, I guess, your daily job, this blogging, this outreach? How is it different from the writing you've had to do before, and how has it maybe improved or changed your writing skills or outreach skills?
So I've done a lot of outreach before I came to NOAO, and so I've given guided tours, and the important thing always is that you need to keep your audience in mind. Like, you can't come with all the special words that we use in science and all the abbreviations, because then nobody knows what you're talking about. It's just too jargony. So you have to break it down and explain concepts in, I mean, sometimes in just a sentence or two, just very roughly, okay, this, for example, redshift just means that something is really far away and that all the lights get stretched and is therefore shifted towards the red portion, hence we call it redshift. Because you don't, if you write a blog post, you don't have a lot of space, let's say, to explain everything in little detail, because then that would be 10 pages and you haven't gotten to the point where you wanted to, which is also part of the reason why we do the background posts, right? But
right.
You have to really break it down on a simpler level and on an easy level, and it helps you to understand what you're doing too and what other people are doing. For example, for me, when I read blog posts from other colleagues, and it's like that's not necessarily my field. It's like, oh yeah, that's really cool. Now I have a better idea of what it is they are doing, because it's just not my field, and they explain it on such a level that it is easy understandable, and you need to use easy analogs that people can relate to and can understand. So it's a lot different from writing a scientific paper where you have lots of details about your exact method, and everything has to, like, basic professional scientific writing is a whole different issue than writing for the general public.
I think it's also a useful exercise for all of us to take a step back and think about the bigger picture of what we're doing, because it becomes very easy to think about the specific thing you're working on, you know, a particular galaxy or a specific aspect, and yes, you can write entire papers about those really fine details, but it's nice to have the broader picture of why that matters, how that fits in the bigger picture. For us, how that fits in the bigger picture of galaxy evolution and the universe we see nearby, and to be able to explain that to other people.
And on a day-to-day basis, really, I mean, now I think, what can we write blog posts about? When someone goes to a meeting, oh, we should prod that person. It's like, just write about what happened at the meeting. Or when we do some outreach, we tell people about that, because we're not only doing the blog, we're also doing some other things. So it's nice to tell people, you know, this is also part of our day-to-day job, so to speak, that we're doing other activities, like we're giving public talks, or we're participating in Project Astro, which pairs an astronomer with a teacher to help them teach astronomy in their classroom. It's really a lot of things. Like when I see emails within the team, somebody's going on an observing run or has got time, like, well, you know, tell us about it, write a short blog post about it. And it's really sort of, it's become routine to think about, yeah, we could write about this, or what else could we write about, and then it comes naturally. It would be a surprise what things we sometimes come up with.
So you're always thinking about how you can put this or that into the blog, right, or how you're going to communicate what you're doing. Yeah.
We've been trying
to have it
and post regularly so that if people are following, they don't get bored and go away, because we haven't posted anything in a while. So.
Right, right.
Yeah, so for example, recently we had a team meeting in Kentucky, and one of our co-PIs of the project, Sandy Faber, she gave a public lecture. And I thought, you know, we could just record it, and because public lectures are aimed at the general public, they're trying to convey a very general, broad idea of what the universe is and what's happening in it. So I recorded it, and we put it on the blog as a video. So it's really things like this that just come up, like, you know, new ideas. We could do this. Let's try it out and see what people think. And obviously, if we would be happy if people comment and tell us, you know, if you like the little videos, let us know. If you don't, also let us know.
Right.
What kind of feedback have you gotten from readers or feedback comments? I'm assuming you don't get horrible comment threads with people arguing, right? Like some websites do. But
we haven't had direct comments on the blogs. The ones we have had have tended to be specific questions. Well, wait, I don't understand one aspect of what you talked about, and then we'll answer that. Most of our feedback has been indirect, from talking to other people at meetings, mainly from other astronomers. We haven't had a lot of feedback from the general public. We've had people share us, so that's been another useful form of feedback. So we've sort of gained a Twitter following and a set of people that share our posts a lot. The same is true on Google+. There's a few people who quite regularly will +1 or share our posts. And so that's sort of been a nice form of feedback.
But so far, everything we've heard from people was really positive. They really liked it. They liked the format of it. And that so many people within the team really participate. I mean, we have more than 50 different people that wrote a blog post at this point, I think.
Oh my
wow,
God.
so it's like a third of the collaboration at this point.
We'd like to have the entire collaboration, but a third is not too bad. Yeah.
I mean, that's really good.
You know, the two of us don't have enough time, unfortunately, to write all the posts ourselves that we would like to write, but a significant amount of what we do is brainstorming, trying to get other people to write, doing the editing and the formatting. And so, yeah, a lot of it is, hey, you just wrote a paper. Paper's already done. It's published. Great. Write a simple blog post about it. And people are pretty open to that, because it's a chance for them to sort of advertise their own work and talk about what they've done in a simple way. And they've already done all of the thinking and all of the work of the paper, so people are drawn to do that. And we've had a pretty good participation rate. And,
I mean, there are people in the collaboration that are, like, a bit scared because they've never done something like this before, and they're a bit unsure on, you know, what level they should write on and if it's okay. So we proofread pretty much every post before it gets posted, just to give people feedback, like, you know, or maybe you should simplify X, Y, Z, or no, this is fine, it's exactly the right level, just so that we don't have too much variation on the level in the posts, and that not something gets too complicated and then scares people off, because we want everybody to understand what every post is about, really.
Yeah, and we have a core group of between 5 and 10 people that are more regular writers. I mean, most people have written one, and that's been it. But some others, they write more regularly. They have more ideas, or, you know, they did it once and they're like, hey, you know, that actually didn't take as long as I thought it would, and it was a lot of fun. And then they're more likely to do it again the next time we ask. So that's been very helpful.
Yep.
Awesome.
Very cool. Very cool. So how long has the blog been running now? Because I heard
a little
about
over
it
a year. So it was last May, so May of 2012.
Okay, so you just hit your blog anniversary a few months ago.
Yes, exactly. And we have something like 120 posts at this point, and something on that order.
Yeah. No, I can add it up. Yeah. So, what do you have an idea of who your readership is? Have you been looking at statistics or analytics, that kind of thing?
Yeah, we've talked about ways to track that. It's a little bit difficult. We know that a significant portion as other astronomers is our own colleagues. We know our friends and families, etc. Those we share things with on Facebook. So most of our Actually, we were just looking at the stats a little while ago. At the moment, most of our stats are coming from Google, so people that are searching for various terms, and sometimes those are astronomers because they're searching a very specific question that only astronomers would ask. And sometimes it's the general public, like the what's it like to work at NASA, a thing that I mentioned, or what are galaxies, things like that people ask. Sometimes they're probably homework questions or something. And then Facebook is the second, and so most of our Facebook followers are probably our own, as the team, friends, families, and then extended reach that way. I mean, now we've been getting some random people that we don't know who they are, where they came from, and they're not astronomers, and that's great. And then we've had a few different ways of getting some of the general public. So Space Telescope included a blurb in one of their newsletters, and after that we got a pretty big spike in readership.
Very cool.
And most of those were the general public, the interested general public that were signed up to be on a mailing list from Space Telescope. But that was helpful.
What's also really nice with the bloggers page, you can see where people clicked on from your to your blogs. You can see they have like a little map, and depending on how many people in that country clicked on it, the darker green it gets. And obviously the majority is in the US, but we have quite a large number of clicks from the UK and Western Europe in general. And at the beginning it was really fun to see, like, ooh, we have like a new person that clicked from Africa, or we have people from China and Taiwan and Indonesia and Mozambique and God knows where, like literally all around the world. And it's really fun to like track. It's like, ooh, we got like a new person from this random country where maybe not many people speak English, and they found our blog, and so it's really fun to watch that too.
That's really cool. I'm looking at your so you've got your post categories on your blog, and it's interesting. Some of the largest words there are life as an astronomer, right, and meetings, and papers. So all the nitty-gritty, galaxies, of course, AGN. But one of them is Astro 101, and I just wondered if you have a sense, sometimes professors, especially Astro 101 type courses, they'll have their students look, at a blog and try to get, again, that sort of everyman kind of explanation of what's going on in astronomy from blogs or other places in the internet. And I just wondered if you know if anybody is using your blog that way, maybe with education or even high school teachers.
Yeah. We've tried to encourage our colleagues that are teaching courses to do that. I don't know how they do, but to share it with their students or put it on their webpage.
Okay, great.
That's the first step. And we've been talking about ways to advertise, so maybe emailing some departments and saying, hey, here's this resource, you're teaching a class, you might want to know about it. We haven't done that yet. But.
And there were a few people at the ASP meeting that, the meeting where we met Nicole, that said, oh, I'm teaching this class and that could be really useful as a resource for my students, so I hope they actually did share it with their students.
Okay.
Yeah. And we had summer students, both of us, undergraduates that did a research project at NOAO with us, and we linked them to, like, here's some basic background before we start working. Why don't you?
That's excellent.
Do a basic introduction, and then we can talk about the details.
I wish I had that when I was an RU student. Oh my gosh.
You get a stack of papers, right?
Yes, a stack of papers.
You've never read a paper before, but go for it. Let me know.
Conference proceedings, yeah.
And that can be really hard. And for some of the basics of describing the collaboration, what the data products are, what kinds of questions we're asking, the blog is perfect for that and the right level.
So it's a student training tool as well, or young researcher training tool.
Yes.
Well, some of the questions that you can see that people Google, it's sometimes even stuff that I would Google myself if I wouldn't know about the subject, just because I need to, like, currently look something up for my research. So I think there are some students and undergraduates maybe that need it for homework or something that actually come across the blog and find their answers that way.
Yeah. So we have a comment and questions, some comments from Michael Jobin on the YouTube page. Hello, Michael. He just posted the Candles blog link on Google+, so yay, thank you for sharing. And he says, I want to learn about young galaxies. Do they have an overabundance of supernovae? So maybe you can address that question.
Yeah.
Well,
depends on how young is the answer, right?
Yeah. I mean, the thing is that supernovas really, in the majority, go off at the end of the life of a star. So it's really the death of a star, and for that to happen, it needs to be a certain age. So really young galaxies should not have that many supernovae, just because they have the stars in them haven't reached that age yet. It's more the older stars, I think, that the older galaxies that have more supernovae, just because all their stars in them start to die out.
It's also a question of just the sensitivity of the survey. So the earliest galaxies in the universe that we're looking for, the galaxy itself is incredibly faint, incredibly small, and so we would not be able to see a supernova in those galaxies. So the types of galaxies where we can see a supernova are a little bit closer. That's sort of the cosmic high noon type time period that I was talking about, sort of halfway in the age of the universe. And that's where CANDELS is uniquely sensitive, because before CANDELS we couldn't detect that far. And so I think that work is currently ongoing, trying to interpret the rates, because a number of supernovae have been detected. And so now what we're trying to do, or people on the team are trying to do, is take how many were detected and how many might we have expected given how these galaxies are forming stars and how old we think their stars are. And then that information will tell us a bit about cosmology in a much bigger picture. But I don't think that the final results of that are out yet.
Yeah. Well, I mean, young galaxies may still, if they form big, massive stars, they don't live very long, and so you're going to get supernova from those guys. But yeah, like you said, they're so distant that we can't collect the photons yet to a significant enough degree to really see that.
We need another Hubble telescope with a much larger mirror, and then we can do that.
Yes.
So how might this work lead up towards I don't know how much you guys are involved in developing science for the James Webb Space Telescope, but how much of the CANDELS work is at what point will JWST be able to pick up the science?
Yeah, so a lot of the work that we're doing really does directly lead into what will be possible in JWST. So the perfect example is the first galaxies. I mean, nobody ever thought Hubble would be able to detect anything that's as distant as the things we are starting to detect. But that's really one of the main goals of JWST is picking up the very faint, very first galaxies, where for us it really is, a few photons. I mean, it's a very faint smudge, and JWST will be able to pick up a large number of them and be able to answer more statistical questions than what we can answer. Right now it's, hey, can we see one? Cool. But what we really want to know is how many are there, how soon did they form, how quickly did they form, how many stars are they forming. These are the kinds of things that will be possible. And then, of course, at the lower redshifts, we'll be able to do things in a lot more detail. So I work on galaxy morphology, which is studying the shapes of galaxies. And we have done this in the nearby universe for many, many years, where we can see beautiful, bright spiral arms and bars and a lot of structure. And at the sort of cosmic high noon period, it's hard. We see some structure, but things are still smeared out, even with the Hubble. Things are small, things are unusual, things are clumpy. So with JWST, with the larger mirror and the better cameras, we'll be able to do a lot of this work in more detail.
And I can personally attest that a lot of those images of galaxies are just, oh, it's another smudge, because we're doing the visual classifications within the team, and when you sit through your set of 200 galaxies per week, it's like some of them are really pretty. You see all the details, you see the nice spiral, and it's beautiful, and then you have all the tiny ones that are just like, it's a blob.
Yeah, I've been coordinating the effort to get all of our team members to look at galaxies and classify them for our own science, and so it's been a useful exercise to get everyone to actually look at all of the images and look at the individual galaxies and see what they're like.
Well, that's one of the interesting behind-the-scene things people don't always realize about astronomy. So they put out these press releases with all these gorgeous images, but so much of the science happens from images that are really not pretty. So how does that affect, if how you tell the story without those visualizations?
It's an interesting example because of today's blog post, which is a new press release. So a month ago or so, there was a press release about a recent paper, and for the image, they were trying to convey what things look like in the early universe, but they actually used snapshots of galaxies that were much closer to us, which gave the impression that that was what galaxies that were very distant looked like. And so our PI, Harry Ferguson, actually worked with the people who made the press release, and they created a new image which actually put real galaxies at those distances so that people could compare, what galaxies nearby look and what galaxies at a distance look like. And so that you can see the changes. So then you have to figure out which changes are simply because they're faint and far away and hard to see, and which ones are because they are actually physically different in terms of what they look like. And that's hard. It's hard to separate those two effects, and that's a lot of what we try to do.
Yeah, that's the image.
Yeah, they get smaller and smudgier as you go backwards in time.
Yeah,
exactly. The Hubble fork isn't nearly as clean as it is, the classical Hubble fork diagram.
Right. Yeah. I mean, there's still a lot of detail in those distant galaxies. You can still say a lot about them, but it's different when we compare to what the galaxies look like that are close to us.
Yeah. And
very cool.
For the work that I'm doing, really what matters is how much light comes from the entire galaxy. So you don't necessarily care what structure there is in the image, as long as you can put a circle around the entire thing and collect and count everything that's in that circle, so to speak.
Yeah.
So as long as the galaxy is not broken up in the detection by itself, you can say, okay, this is all the light that comes from the galaxy, and of course that's averaged then across the galaxy, just because you're only looking at one circle and not in lots of tiny circles to see how it varies across the galaxy. But it makes it a lot easier, because for that you don't care that it's a smudge, right? You just care that you get something from it, that it's there. You care that it's there.
So do you have a particular post that was either really challenging to write or that was really fun to write? Maybe something that really stands out of the stuff that you've done?
That's a hard question. I think I wrote a post about myself, so we have one category where we do the interview with the astronomer of the month, and for the people that contribute a little bit more often, we try to do that they write a blog post about themselves, just sharing similar things as we would answer in the questions. And that one was actually quite a lot of fun to write, because you can tell a little bit more personal about yourself, and it's really easy to write because you know yourself, and it's a quick thing to do. But it's also nice to just show people we're all just normal people. Yeah. We do science, but we're not
mostly
more normal than others.
Yeah, of course, there are the exceptions, but it's not like we're all crazy scientists with crazy hair and our lab coats and we don't see the outside ever. That's just not the way it is, right? And it's nice to see how everybody got to do what they're doing, how they got interested in astronomy, and what different paths they took. So those are always a lot of fun for me.
I think I had a lot of fun writing. I had an observing run last December, where I was using Mossfire, which is a new spectrograph on Keck, and it's very new and very exciting to use, and so it was a lot of fun to write that post, even though our weather wasn't great. I mean, part of the post is about, oh no, it's this time and the weather's bad, what's going to happen, and it kind of was an exciting story. So
yes.
That was
probably gave you more time to actually blog, because you can't be on this.
Right, and we got some data. So there was a good
What also was really fun for me, it's not on the blog yet, but we hope to put it soon. During the team meeting, we started to have people just record a short video message. And one of them was, we asked someone, he wanted to talk about how it matters what we're doing in a bigger picture. And I'm not going to like tell you what he said because you're gonna have to go watch at the blog for it. But I thought that was really fun just to hear his view on why he thinks it's important. It was really interesting, and we hope we can get some more people of the team to do that, just to give you a little bit of a broader aspect. And as for the most challenging posts, I think it's really the ones that go towards describing the result of a particular paper. Mm-hmm. Just because it's so specific to a degree that it's sometimes hard for people to make it understandable enough and to really break it down. But we have a lot of contributors and blog posters that manage that quite well.
Yeah, I was thinking of a couple of the background posts I wrote. So I wrote one about galaxy mergers, and I wrote one about infrared galaxies. And they're sort of subjects we've worked with for such a long period of time. Well, we understand why they're important, and you almost forget, sort of the bigger picture of why they're important. So I found it a bit challenging to be able to tell that story. Say this is what happens. These are what the effects are. This is how they'll affect galaxies over the age of the universe, and to tell that in sort of a broader picture with simple words, I thought was kind of a challenge.
And I know, Jan, we were just at Astronomy together, so there's we're trying to push forward a couple new projects which I've let languish, sadly, in my inbox. But we're trying to get more of the astronomy blogs to promote each other and be able to share each other. So we've got a lot of great scientists who are using blogs as a tool of outreach and communication. And so it's so cool that you guys have been doing this for over a year. And really putting that content out there for people, which is really cool. Yeah. So yay, there'll be more. Yes. We will be shamelessly promoting each other till the end of time, because it's all such good stuff. It's all such good stuff. Yeah. So yeah.
Has the blog or writing for the blog, has it changed how you write or how you communicate? So you've been doing it about a year. Do you see any difference from when you guys started?
I think so. I think a lot of how I talk to people one-on-one, if you meet someone and they ask you what you're doing, even another astronomer at a meeting, they may not be in your field, and I think it's helped me formulate in my own mind some of the ideas, some of the bigger picture, and the collaboration as a whole, right? So now I don't only know about my own science. I have a much better idea of what everybody else is working on and why our survey is important, and so I'm able to convey that to other people much better than I did before.
Yeah, it certainly gives you practice in simplifying the idea and still bringing it across accurately. And I have to say it also helps to just, as Jan said, to know what other people in the team are working on. And to
because it's such a large collaboration. How do you keep track of everyone?
Exactly, and especially when they write about their recent papers, because it means you can get the gist of what the paper is about without having to read the 20-page paper. And that's, I mean, reading a paper takes a lot of time, and especially if you want to read it in detail, and just to have a quick summary of the basic point of it on the blog is really nice, because I think we had at the recent team meeting, our PI made a statistic that since the beginning of the survey, the team wrote about, 2 papers a week?
A paper every 2 weeks.
A paper every 2 weeks,
including things that are in progress right now.
And that's
amazing.
That's just
papers. Just so many people, right? And so many different topics.
And that's just papers within the collaboration, and you can imagine if you want to keep track of everything that's going on in your field in the entire astronomy community, that's a lot more papers to read, and it's just hard to keep up with that.
I mean, a good example is at the AAS meeting earlier this year, Janine and I did one of these big hyperwall presentations. We had this big screen in the middle of the exhibition hall where we had to talk about candles, and we were asked to talk about it because we were going to be at the meeting. And we were talking about other people's work and not just our own. And it was actually useful to go and skim through some people's blog posts where they've written summary. This was a really quick talk. It was aimed at everybody. But it was nice to have that quick summary right at our fingertips of who was working on what and why it was important, and be able to incorporate that in our talk.
Yep.
Yeah, you need that in a colloquium talk too. Talking to a department of astronomers, you want to have that broad baseline and show people what the whole picture is, the whole picture of the collaboration of the field, especially if you've got grad students and undergrads in the audience. I mean, that's really helpful too. I hope so hard that the Hyperwall is coming to AAS this year.
I think it was this year and it was last year, so I would hope that they do it again. But it seemed to be pretty fun. Yeah, I know, but it seemed to be
the gas education funding's in such a state of I don't know. So when the government starts working again and they're allowed to answer their email, I'm sure I'll be asking. Can we join you? Because I think we were set up right next to the Hyperwall. We were using some of their table space, and it was so much fun to see everyone's presentations, and we got to use it for when the kids came through as well. So yeah, fingers crossed, people, that this thing will get resolved. So I don't want to dwell too much on that, but I'm cranky about it. So. What's that?
I think everybody is.
Yeah, we're a little cranky. Oh, yeah. But we keep going on it, and Lourdes actually commented, "Thank you. I'm glad you guys are keeping going on during the shutdown. So that is not affecting any of us here directly. So we're we're still here." And Michael Jobin just commented, "Cosmologists should have bigger paychecks." Thank you, Michael.
Now your comments.
As long as I can pay the rent, it's okay. So, all right. So I think I'm going to wrap up with a few announcements, and then afterwards I will give you guys a chance to give us some last parting thoughts about the blog, and maybe give us a promo of what's coming up for the blog, coming up soon, if you know. So today's Wednesday, which means on Friday we have the weekly Space Hangout at noon Pacific. Fraser Cain hosts a bunch of us rowdy scientists and science journalists to talk about the top news in space this week. So join us on Friday for that. Sunday night's the weekly Space Hangout. They are slowly, as you can see, it's getting darker in front of my face. They are slowly pulling back the virtual star party time. I think it is back to 8 p.m. Pacific right now on Sunday night. And then Monday, I think, is noon Pacific as well as Astronomy Cast. Bracey and Pamela Gay record a new episode of Astronomy Cast every week using Google Hangouts. So join us for any of those. It's the upcoming schedule. And Georgia and I will be back next week for Learning Space. So Jan and Janine, why don't you give us some parting thoughts about the Candles blog?
Sure. Well,
do you want to start?
Well, I'd like to say we're always looking for feedback, so please feel free to comment on our posts, comment on our Facebook page, tweet us. If you have any suggestions or ideas for posts or things you'd like to see, we're always willing. We've been thinking about starting an Ask an Astronomer type series, so that might be a great kickoff if people have burning questions that they'd like to know about. I don't know if you want to say anything about upcoming posts.
And well, upcoming, I already mentioned it earlier. We'll start with a video blog post and see how that goes, so please let us know how you like those. If they well received, we might do them more often. As always, some of the astronomers are shy, they don't like to be in front of a camera, so we'll need some convincing. But
we have a few posts about recent meetings in the work, so Dot Astronomy that Nicole mentioned, as well as Galaxy Zoo, for those of you that are familiar with that project. They had a meeting last week that we'll be writing a post about soon.
And otherwise, we hope that we're going to have a lot more papers to write about.
Including our own.
Yeah.
Yay. So there's the website. So it's candles-collaboration.blogspot.com. Candles is spelled not like the things you put on fire, so do note that. You should be able to, so if you see that up on the screen, CANDELS, that's the name of the survey. And that is, so that stands, so let's see, this isn't bad for an astronomy acronym. Cosmic Assembly Near Infrared Deep Extragalactic Legacy Survey. Like, that actually makes sense. You know, some astronomy acronyms.
My brother has learned in the meantime to spell candles this way and not the other way. Yes. Correct me at the beginning, it's given up now. So.
And this one's easily Googleable. So if you Google with that spelling, you'll find our webpage, you'll find our blog, you'll find our papers. So that's a nice thing.
Yes. And it's not too tortured of an acronym. I appreciate that. I appreciate it a little, but it makes
it gets some giggles during talks.
Well, yeah, I guess that infrared is kind of hidden. near-infrared.
Sometimes you have to do that. Yeah. Flexible. Yeah.
Well, thank you so much for joining us this week. It was really great to talk to you guys.
Yeah, and thank you so much.
Thank you for having us. Great.
Thank you, everyone, for watching Learning Space. So, bye, everybody.
Okay, bye. See you next week.
Bye.
Hi, everyone. Welcome to this week's Learning Space. My name, which is not on my lower third because it's broken, is Nicole Gugliucci. I am a postdoc with CosmoQuest. And we bring you, I have my co-host, Georgia Bracey.
Hello.
Hello. And we have special guests, Jehan and Janine. So, hello.
Hello.
So we are a weekly show about topics in astronomy and space science, education, and outreach. And so thank you for joining us once again. The Hangout toolbox is all different and changed, and I can't make my lower third work, so sorry about that. But all the other awesome people have their names up. So
you don't need lower third, Nicole.
Yes, you're all seeing my mug every week. Gosh, it's true. You all see my silly mug. But also there's been changes to the comment tracker, and so I am watching the event page comments separately from the comment tracker because I can't figure out how to get them in the new system. So be sure to use the event page for your comments. I'll be watching that, and then the comment tracker is picking up the YouTube comments as well. Fingers crossed. If one source seems not to be working, try the other. So feel free to ask questions of our guests or comments.
Yeah, I do need the coverage in a broad wavelength range in order to be able to tell anything. And each of those fields has about 40,000 galaxies in them.
Wow.
Times 5, that's a lot of galaxies, like 200,000. We're still waiting for data on the last field. It's all observed now, but the catalogs aren't ready yet because the images just are all the data's just been taken. The images are being processed now, and there needs to be, sources need to be detected, and then you can extract the information of how bright they are, and then we have catalogs and can use them.
Yeah, so we're at an interesting milestone right now that all of the data has been taken, and it's taken 3 years.
Oh, very cool. Yeah.
It's all been all finally taken, and the images are in hand. But that's really when the real work starts, of trying to derive all of the interesting information from the images.
Yeah.
So I guess I could say some of the main science goals. So we only work on really small parts, right, our own science interests. But there's something like 150 collaboration members, and these are all over the world, in many different countries. Other professional astronomers, their students, their postdocs, and all working on different aspects, but sharing the same resources. That's really the main idea behind a collaboration. Janine, introduce herself.
Hi, I'm Janine Four. I'm also a postdoc at NOAO, and Jehan already told you what exactly that stands for. I'm working for the same survey for CANDELS, and my tasks there are mainly to derive galaxy properties, so how heavy is a galaxy, how old is a galaxy, and to do that for all the galaxies that we have in the survey. And then if you know how far away one of those galaxies is, you can constrain galaxy evolution with that and see how they actually evolve over time. I'm also not really using any of the Kidd Peak telescopes. We like the space-based ones.
That's fine. That's fine. I personally could not handle having my dissertation on a rocket ever, so I set it down base.
Well, as a postdoc, we don't have any functional duties, so everybody else at the observatory has duties with the observatory. We get to spend 100% of our time just on research, so that's why we don't have that direct connection.
And some spare time on CANDELS outreach.
Yes.
Yes, all that copious free time you have.
Exactly.
So maybe you guys can tell us a little bit more about the CANDELS survey. So what is that? So that's using the Hubble Space Telescope. Comment along as we go. We already have a hello from Lourdes. Hello, Lourdes. So why don't I start off asking Jehan and Janine to introduce themselves and the research that they do, and then we'll get to talking about the blog.
Sounds good. All right. My name is Jehan Kartaltepe, and I am a Hubble Fellow, which is a postdoc, at the National Optical Astronomy Observatory. So that's NOAO for short. So NOAO runs the Kitt Peak National Observatory facilities. I actually don't work with those facilities. I just work on research here as a postdoc, and I work on galaxy evolution broadly. I'm mainly interested in galaxy mergers and how when two galaxies collide with one another, that changes the course of a galaxy evolution and how they have changed over time. So I'm mainly looking at galaxies that are really far away from us in the distant universe. And in order to do this, I participate in a number of large surveys. And so one of the surveys is one that we're going to talk about today called CANDELS. So CANDELS is the largest HST survey to date, which is studying these galaxies in the distant universe.
What is that survey, and what's kind of the overarching goal of it? How much data does it have? How many people are involved? What's the scope of this project?
Well, after the most recent Hubble servicing mission, a new camera was installed called Wide Field Camera 3. And the new exciting thing about this camera is that it's observing the universe in the near infrared instead of in the optical. So a lot of previous surveys were conducted in the optical. The benefit of a large survey in the near infrared is that for galaxies that are far away, their optical light that they emit is shifted into the near infrared. So we see them differently than we see local galaxies. And so by using this specific camera, we can see galaxies in a comparable way to the way we see galaxies in the nearby universe. And so this is perfect for galaxy evolution studies, so we can compare things one-to-one. The idea of the survey is we are observing 5 different fields, all in different portions of the sky. But these are 5 fields that have been well studied for many years. So in addition to our near-infrared data, there is data from a number of other facilities, both in space and from the ground. So we can put that all together, and Janine can then use that information to determine some of their properties.